everyone, this is an examples video for substitution and indefinite integrals, and in this video I'm going to focus on examples where just some manipulation is needed, so we'll call these maybe medium difficulty. If you're looking for a really kind of detailed explanation of how substitution works, this might not be the right video for you. I do have a video where I break all of that down if that's what you're looking for. Otherwise, these are the 4 examples that I'm going to go through in this video. So if there's a specific example that you want to see, you can see the 4 that I'm going to go through. You can go through and find the example. Otherwise, you could also use this as a way to kind of quiz yourself and see how much you understand. And that's just another way. So let's jump into it. So starting with the first example. So I've got 5x times the square root of 3x squared plus 2. Okay, so for my u in this case will be 3x squared plus 2, and I get confirmation that I chose the right u when I take my first derivative. So my du in this case is 6x dx, so this at least gets rid of this x part here. Now, I'll show you 2 different ways that you can do this. So one way that you can do this is the way that I like to think about this, but I've learned that a lot of people don't like this. So one way is I kind of look through the problem and I'm like, okay, so I've taken care of this x and this dx. So that's this part and this part. The only part that's not really covered in this is the 6. So then what I do is I divide both sides by the 6. So I rewrite this as 1/6 du equals x dx. And then I can replace basically the x and the dx with this 1/6 du. So that's one way of doing that. And if you do it that way, so I'll just show you this. So this would be 5 times the square root of u times 1/6 du. There's way 1. However, if you don't like that explanation, I'll show you another way that you can do this. So the other way that you can do this, so I've seen a lot of people solve for dx. So basically then you rewrite du 6/x equals dx. So I just literally solve for dx. And so what I see some people do sometimes is they basically write out the problem. So I only replace my u, and now where I have my dx, I replace all of dx, this dx here, with this part. So now this dx becomes du over 6x. And then what I see people do is they'll kind of look across the landscape of this problem and see what will cancel out. So now you can see by looking across here, these x's will cancel out, so that's what I've got. Okay, so if I do it that way, so then what I'll get here is that this becomes really 5/6 times the square root of u du. Or going back to this way that I was doing before, I literally get the same thing, right? So I can also get, if I rearrange this now, 5/6 times the square root of u du. So it totally doesn't matter which way you like to think about this, so figure out the way that works best for you. So I'll try to switch back and forth between these, but I just always want to make sure I show 2 different methods of this. Now let me clear this out because I need the space. Okay, so also one other thing, I want to rewrite the square root of u as u to the 1/2. It just helps me to kind of think through what I need to do with the exponents a little bit better. So now we can actually integrate. So, I'm integrating, so this will be 5/6 times, so let's see, this will be u to the 3/2, which means that I need to put 2/3 down here. So all that plus c. So now this becomes 5/9 times 3x squared plus 2 to the 3/2 plus c, and that'll be my answer. Okay, moving on to b now. So for b, so probably this will be my u, that would kind of be my first choice. So let's go ahead and work this out. So my u is going to be 3x to the 3/2 plus 1. And then my du in this case will be, let's see, this will be 9/2 x to the 1/2 dx. And so once again, as I look through this, so I'll explain this just one more time. So as I look kind of across the landscape of this, so I notice that I have covered this x to the 1/2 and this dx. So that's what I replace when I actually put this all back in. And then what I haven't replaced is this 9/2. So I'm going to multiply by the reciprocal of 2/9. So I'm going to call this 2/9 du equals x to the 1/2 dx. So I'm going to replace now these pink parts with this 2/9 du. So if you do it that first way, you get 5 cosine of u times 2/9 du. Now, like I said, people also do this another way. So if I want to take this and solve this for dx. So this would be the alternative way that you can do this. So if you solve this for dx, you'll get, let's see, this will become 2 du over 9 x to the 1/2. So that's what this ultimately will be if I solve for dx. So if I want to use this method, so then basically I just replace my dx with this. So this would be the alternative way that you can do your substitution. So I've got 5x to the 1/2. I can go ahead and at least replace the inside of the cosine. And then where I have this dx now, I'm going to replace it with all this stuff here. So this will be times 2 over 9 du x to the 1/2. Now as I look across the landscape of this problem, so I can see that x to the 1/2 and x to the 1/2, those both cancel out. And I'll literally be left now with the same thing as over here. So it's just two different ways of doing the same thing, but some people really, one way resonates with people and another way, it's, you know how it goes. Okay, so now I've got really 10 over 9 times the integral of cosine of u du. So that one's nice and easy peasy. So let me clear this out just so I can make a little space for myself now that we've got the same problem in either technique. Okay, so now if I integrate this, this becomes 10 over 9 sine of u plus c. So then this is 10 over 9 sine of 3x to the 3/2 plus 1 plus c, and bada bing, bada boom, we're done. Okay, so moving on to c here. So in this case, so one thing that you kind of want to remember is that this sine squared of 5x plus 2, this is the same as, so you could write it like this or you could write it like this. So sometimes people need to actually write this out for themselves to kind of get their brain to see it in the right way. So what I actually want to set for my u is this sign here, so that ultimately this will turn into u squared. So I have my u equal to sine of 5x plus 2. And the reason I want to set it like this is because then when I take the derivative of this, so then you'll see why. So when I take the derivative of this, I get cosine of 5x plus 2. Now I have to use the chain rule, so I have to multiply by the derivative of the inside function, which is 5x plus 2. So I multiply this by 5. Multiply by 5. Having problems with my pen here. Dx. So this is the only way, if I take the derivative of this, it's the only way I can have that inside intact. And so now I've just got to kind of manipulate the problem to make it work for me. So in this case, what I'm going to do, I'm just going to divide each side by 5. So I get 1 over 5 du equals cosine of 5x plus 2 dx. Or alternatively, you could use that method where you solve for dx, whatever way works for you. But ultimately, what you're going to get after you make all your substitutions, this will become the integral of, we'll say 1 over u squared times 1/5 du. And if I want to rearrange this, which I do, so let me bring the 1/5 actually out in front of this integral. So I will just erase this so that I can restate this and just kind of move along with the problem. So I've got, we'll call this u to the -2nd instead of 1 over u squared. Okay, so now that's what I actually have to integrate, so we can do that. So this will be 1 over 5 times -1 times u to the -1st plus c. So there's kind of what I'm left with. So now I can write this as the final answer. So this will equal -1 over 5 times sine of 5x plus 2, all of that plus c. And there's your answer. And now for this last one. So this one actually requires a little bit of manipulation, but it also requires a little bit of cleverness. So notice that I have this fraction here, but it's not like I can cancel the 5 and the 8 exponents. This can't be broken up. So that's kind of an issue. And so now if you're thinking, well, what do I want to set for my u? So if I just kind of go through a little bit of a process of elimination. So let's say that I wanted to set x to the 8th. So why wouldn't this work? This wouldn't work for a multitude of reasons. One, notice I do not have x to the 7th anywhere in here. Also, so this wouldn't help me take care of this. And then, you know, if I could find x to the 7th, if I could make this into x to the 7th in some way, this would still be a problem because then I would end up with a dx in the bottom. So this just doesn't totally work for us. So that's kind of a hint then that this is not the right path. And part of working with substitution is kind of knowing how to troubleshoot and get a little creative. Okay, so now let me try again. So let's say that I've got u equals x to the 5th plus 4. So then my du in this case would be 5x to the 4th dx. Now, part of, maybe you're thinking, okay, we know, like, I can tell just by looking at this that this isn't going to work either. And part of why you want to write these down actually is so that you can get a little bit more creative with this. So the first u that I chose, there was just no way to really turn this x to the 5th into a 7. However, now that I'm thinking about this, what I really need is I need x to the 4th. How could I get to this? Well, I've got the square root of this whole thing, so this is where the creative thinking comes in. And sometimes when you're looking at these, so sometimes the square root is just kind of noise and you're just kind of working around it and it, like, you're not really doing anything with it. But in this case, I'm actually going to be leveraging the square root. So what I want to do here is I want to rewrite this problem now. What is the square root? What is the square root of x to the 8th? Well, I would just divide really 8 by 2, so this would be x to the 4th. And that helps me, right? Because if this is x to the 4th, then that actually helps me get to my du. So I can rewrite this problem here. I can rewrite this now as x to the 4th times 1 over x to the 5th plus 4 dx. Okay, and now I can totally actually work with this. And I'll do this now in the method where I actually solve for dx in case some of you prefer that method, so I'll just show you that way. So if I'm going to do that, so if I solve for my dx, let's see, so my dx will equal du over 5x to the 4th. Okay, so I'm going to go ahead and make these substitutions using this method. So I'm going to leave the x to the 4th alone. This is the square root of 1 over, so the square root of 1 is just 1, by the way, so we can really write this as 1 over the square root of u. And then now where I had my dx, now I'm going to replace it with this part here. So this will be times du over 5x to the 4th. Now as I look across the landscape of this problem, I can see that the x to the 4th and the x to the 4th will cancel out. And so now I get, really, we'll call this u to the negative 1/2 du. Oops, and then 1/5 out here. 1/5 goes out on the outside. Okay, and so now that I can work with, right? So this will become 1/5 times 2 u to the 1/2 plus c. So ultimately this becomes 2/5 times the square root of x to the 5th plus 4 plus c. And so there you have it. So it required a little bit more creativity and also a little manipulation. Now if you're looking for more problems kind of in this vein where you've really got to get creative, I have another video, and I actually explain in my longer explanation video kind of how to attack problems like this or harder ones. And then I have another example video of just straight up difficult problems to work through. So check those out if you're looking for more. Okay guys, thanks for watching. That's it for this video. I'll see you next time.